In this diagram is given, and it said that line OT bisects the angle POQ. So the angle POQ, this angle is bisected by OT. OPQ and this angle, these two angles are right angles. And of course OP, this one and this one are radius, and it's given the radius value is given as 5 centimeter, and the length of this arc here, this much, is given as 9 centimeter. So first we have to find what is the value of POQ. So what we will do, we know that the length is, if we say POQ, angle POQ is theta, then we know the length of arc PQ, that is this length, will be r times theta, when theta is in radian, and that's 9. So theta will be 9 over 5, radius is 5. So that's the value of theta, that is POQ in radian. So that's there. Then we have to show that triangle OPT is congruent to triangle OQT. So OPT, this triangle is congruent with this triangle. This one is congruent to that one. So we can see that these arms are equal. I will draw with a different color. These arms are equal, both radius. This is a common arm, and this angle is equal to this angle, bisecting. So side angle side, if we write side angle side, and so these two triangles OPT and OQT will be congruent because of side angle side equality. Now the length of PT we need to find out. So this one I will draw the triangle on the next page, OPT. So like that, it's there. So this is O, this is P, this is T. We need to find the angle PT, sorry, line PT, the length PT, and this is a right angle. And this one 5 centimeter we know. So this angle we also know. This will be half of POQ, which is half of theta, which is half of 9 times 5, so 9 over 10 radian. That is the angle here. So this is a right angle. So if we write tan theta, that will be opposite arm over adjacent, which is OP, and that will be, so PT is not known, let's call it maybe whatever, let's leave it PT, and OP is the radius, so PT r times tan of 9 over 10 in radian. Now when we do it, we have to remember in calculator, we have to change the setting into radian. Sometimes we forget to do that, and we end up getting the wrong result. So this angle is in radian, so when we are using calculator, we have to set the angle into radian. So whether we are dealing with radian or degree, we have to be careful about that, and we should set the angle accordingly. So that's done there, and if I plug in these values in the calculator, I get PT as 6.3 centimeter. So that's done there. Now the last part, find the area of the shaded region. This shaded region, that one's area is needed. So what can be done? I can try finding the area of the full quadrilateral there. So that will be twice of each of the triangles. So 2 times triangle, say OPT, this one, that will be the full quadrilateral, minus the area of this one, this major segment, if we call it this major segment, if we find the area of that, and that one's area is given by the formula half r square theta. So that's there. So I just plug in the values. This one is 2, and the triangle area is half times 5 times 6.3, and this is minus half 5 square times 9/10. So this one again, this is the area of the triangle, and twice the triangle is the area of this full quadrilateral or quadrangle, whatever, quadrilateral, sorry. So this one, and minus the area of the major segment. If we subtract that, we get the black shaded area, and that's what we want. So that's there. And here also we have to remember, when we are finding the minor segment, this angle r square theta, this theta will be in radian. So if we have the angle in degree, we have to convert that into radian. Now we have it in radian. So these things are very important, because otherwise we will get the wrong result. So this is there, and once this calculation is done, it's approximately 9 centimeters square. So that's it.